Unit 4, Part 2, first topic, contextual considerations in data visualization. Data visualization isn't just about showing data, it has to be designed with the context in mind. This means thinking about who will see the visualization, what its purpose is, and where it will be shown, like in a report or on a website or during a presentation. These factors affect important design choices such as how simple or detailed the visualization should be, whether it needs interactive features, and how easily it is to use. When designers consider the audience's knowledge level and the goal of the visualization, they create visuals that are more effective, meaningful, and easy to understand. When designing data visualizations, it's important to think about who the audience are and how much they know about the topic. People with different levels of expertise need different types of visuals. For the general public, simple and engaging visuals like infographics work best because they avoid technical terms and keep things easy to understand. Business users usually prefer dashboards with clear charts that highlight important numbers and comparisons. On the other hand, data analysts or researchers need complex and interactive charts that show detailed insights for deep analysis. For example, a stock market infographic for regular people might use simple bar charts, while a financial analyst would want more advanced charts like candlestick graph and moving averages to study trends closely. The purpose of visualization. What is the goal? The purpose of a data visualization plays a big role in deciding how it should look and what details to include. Different goals require different designs. For example, if the goal is exploratory analysis, helping users find patterns or relationships, interactive charts like scatter plots or heat maps work best. However, if the goal is explaining something clearly, then infographics or simple annotated bar and line charts are ideal to tell a clear story. For decision making, dashboards with real-time updates and key performance indicators, that is KPIs, help leaders take quick action. If the goal is persuasion or marketing, story-driven visuals or interactive infographics engage the audience emotionally. For instance, a sales team business dashboard should focus on real-time KPIs, while a scientific report might need detailed charts with statistical information. Presentation. Where will the visualization be displayed? Where a data visualization will be shown, the medium of presentation also affects how it should be designed. Different mediums need different sizes, formats, and levels of detail. For example, visuals for print like reports or posters should be high resolution and easy to read with clear labels because they won't be interactive. Web-based visualizations such as dashboards on websites can include interactive features and real-time data updates to help users explore information. For mobile devices or social media, designs need to be simple, compact, and easy to use on small screens with minimal text. When showing data in presentation slides, simple charts with little text work best to keep the audience focused. For instance, a visualization made for a mobile app should have touch-friendly controls and little text, while a research paper needs detailed labels and citations to explain the data clearly. How contextual considerations influence design choices. Contextual factors like audience expertise, purpose, and medium directly shape how a data visualization is designed. For audience with less experience, visuals should be simple with easy to understand charts, tooltips, and minimal text, like a climate change infographic for students using icons and soft colors. Experts such as scientists need detailed labels, multiple filters, and in-depth data like complex temperature anomaly graphs in a research report. The purpose also matters. Explanatory visuals should be focused and clear with helpful annotations, perfect for a newspaper article explaining inflation trends. Exploratory visuals like financial analyst tools need interactive filters and options for comparing different scenarios. Finally, the medium affects design too. Print visuals are static and high resolution. Mobile designs use minimal elements and bold text for clarity, while web-based visuals can include interactive features like hover details. For example, a healthcare dashboard requires real-time updates, but a research poster needs detailed annotations. The goal and supporting data. Before creating a data visualization, it's important to clearly understand the goal and the data that supports it. Ask yourself, what do I want to show or prove? And what data do I have to back it up? For example, if the goal is to show trends over time, you'll need time series data and a line chart works best. To compare categories like sales in different regions, a bar chart is a good choice. For showing part to whole relationships such as market share, pie charts or stacked bar charts are effective. If the goal is to persuade the audience about an issue like plastic pollution, a pervasive infographic with clear facts and visuals will work well. For instance, to show vaccine progress, you'd use data on vaccination, rates over time, population totals, and regional details to create a meaningful visualization. Knowledge before structure. The principle of knowledge before structure means that before deciding how a visualization should look, you first need to understand your data and your audience well. It's important to know what your audience already understands and what key insights the data reveals. Only after this should you choose the best visual format to clearly communicate the message. Instead of starting with I want to make a bar chart, ask yourself, what story do I want to tell and what does my audience need to learn? This approach ensures your visualization is meaningful, clear and useful. Next topic, significance of selecting appropriate visual encodings in data visualization. Visual encoding means using visual elements like color, size, position, shape and texture to represent data. Choosing the right way to encode data is very important because it makes the visualization easier to read and understand. Good visual encoding helps people quickly see patterns and relationships, avoids confusions or misleading impressions, and makes sure the data can be understood by different audiences, including those with visual impairments. It also plays a key role in telling a clear story with the data by highlighting the important insights. Key types of visual encodings and their significance. Natural order. Natural order means using visual encodings that follow a logical, meaningful sequence based on the data. For example, some data like temperature, age or income has a natural progression from low to high. When visualizing such data, it's important to show this order clearly. Using a color gradient from blue that is cold to red that is hot in a heat map is a good example because it matches how we naturally understand temperature changes. Similarly, arranging bars in a chart from smallest to largest helps people quickly see the order of values. On the other hand, using random colors that don't match the data's order, like red for low temperature and blue for high, can confuse the viewer. In this example, blue represents low temperature, red represents high temperature. This gradient color scale helps viewers quickly understand the temperature progression from cold to hot, making the data clear and intuitive. Distinct values, avoiding confusion with clear differentiation. Distinct values means that when showing categories or groups in data, each one should look clearly different from the others. Using colors or shapes that are too similar can confuse people and make it hard to tell categories apart. For example, a bar chart that uses blue bars for men and red bars for women helps viewers easily see the difference. But a pie chart with many shades of green makes it difficult to tell categories apart and can lead to misunderstanding. It's important to use contrasting colors and clear labels to keep the visualization easy to read. In this example, using different colors for men and women makes the categories easy to distinguish. This clear color difference helps viewers quickly and accurately interpret the data. Redundant encoding, enhancing understanding with multiple cues. Redundant encoding means using more than one visual cue to represent the same information. This helps people who may have trouble seeing certain colors or details, like those with color blindness, and makes complex data easier to understand. For example, a scatter plot that shows men as blue circles and women as red squares uses both color and shape to differentiate groups. This is better than using only color because some users might not be able to tell colors apart. Adding labels or patterns alongside color also improves clarity and accessibility. In this example, circle with blue color is used for indicating men, square and red color is used for indicating women. So, both shapes and colors are combined for clarity. Even if someone is colorblind, they can still tell the groups apart by using the shape. Next topic, how proper encodings enhance readability and prevent misinterpretation. Proper visual encodings make data easier to read and understand while reducing mistakes in interpretation. Using natural order helps viewers follow logic trends like increasing temperatures which avoid wrong comparisons. Distinct values make sure categories are clearly different by using contrasting colors so people don't get confused by similar shades. Redundant encoding adds extra visual cues like shapes combined with colors, giving multiple ways to understand the data and helping those with color vision difficulties. Together, these techniques improve both clarity and accuracy in data. Information versus persuasive versus visual art. Information visualization is all about presenting data clearly and accurately so people like analysts, researchers, and decision makers can understand and analyze it easily. It uses clean and structured designs without unnecessary decoration, focusing on honesty and data integrity. Common tools include bar charts, line graphs, histograms, and scatter plots. For example, a line chart showing COVID-19 cases over time in different countries help experts discover trends and make decisions based on the data. Persuasive visualization. Persuasive visualization is designed to influence opinions or support a specific viewpoint using data. It targets the general public, stakeholders, or marketing clients by using bold colors, highlighted numbers, and clear annotations to draw attention to important messages. These visuals often include infographics or dashboards that guide the viewer's interpretation with text or titles. For example, an infographic showing that 80% of plastic waste comes from just 20 companies aims to raise awareness and persuade people about the impact of those companies. Visual art with data. Visual art with data uses data to create art that inspires emotions or highlights important issues rather than focusing on exact numbers. It aimed at the general public and shown in exhibitions or creative projects. This style is more abstract and artistic, often turning data into beautiful visuals like creative maps or artistic graphs. For example, an artwork that shows air pollution as a color gradient over a cityscape helps people feel the impact of pollution in a powerful and visual way. Next topic, looking at data as a reader. When designing a data visualization, it's important to think about the reader's perspective. Ask who will be looking at it. Is it a business user, a student, a policymaker, or the general public? Understanding what they want to learn helps you focus on the key trends, comparisons, or important surprises in the data. Also, consider how much they already know. People new to the topic need simple and clear visuals, while experts can understand more complex charts. Principles to follow while designing for readers. When designing visuals or data presentation for readers, it is important to keep a few key principles in mind. First, always focus on the reader's goal. Think about what they need to understand or do with the information. Next, simplify complex data by breaking it into easy to understand visuals so it's not overwhelming. Use colors, sizes or labels to highlight the most important points and guide the reader's attention. Organize everything in a way that feels natural to read, usually from left to right and bottom and top to bottom. If the design is digital, try to include interactive features so users can explore the data more deeply. Finally, make sure all labels, legends, units and sources are clearly shown so readers are not confused about what they are seeing. Following these principles help create clear and effective designs that make understanding data easier for everyone. Design techniques for reader-centric visualization. When creating reader-focused visualizations, there are some helpful design techniques to keep in mind. For interactive charts, use tooltips. These small pop-ups show extra information when you hover over parts of the chart. Annotations are also useful to explain sudden changes like spikes, or dips in the data. Another technique is progressive disclosure. First show a simple summary, then let the readers dig deeper if they want more details. When choosing colors, be careful to pick palettes that everyone can see clearly, including people who are colorblind. Finally, it is important to get feedback by testing your visuals with real users. Ask them if the visualization is easy to understand, what insights they get from it, and if anything feels confusing or distracting. This feedback loops help you to improve your design to make it even clearer and more useful. Next topic, principles of effective and ethical data visualization design. When designing data visualization, it's very important to understand the reader's context. This means knowing who your audience is, what they expect, and how much information they can easily process at one time. For example, experts who are familiar with the topic can understand complex charts, but general audiences need simple visuals to avoid confusion. Cultural differences also matter because colors or symbols can have different meanings in different cultures. Additionally, think about how much time your reader has. Someone in a hurry needs quick insights, while an analyst might want to explore details more deeply. For instance, a financial expert might use a detailed candlestick chart to study stock trends, but a regular person would find a simple line chart easier to understand. Keeping the reader's context in mind helps make your visualization clear and effective for everyone. Creating data visualizations, it's very important to make sure they match reality and stay consistent. First, your charts should accurately reflect the real world data without misleading anyone. This means axes should be scaled correctly and time should always flow from left to right. For example, if you're showing population growth, don't start the y-axis at 80 million if the actual lowest number is 50 million. Doing this can make differences look bigger than they really are. Using an accurate scale tells a realistic story. Second, consistency and patterns help people understand data better. Use the same colors, labels, and formats throughout your visuals so readers don't get confused. For instance, if blue means profit in one chart, it shouldn't mean loss in another. When you keep visuals consistent and emphasize patterns like trends, it becomes much easier for readers to follow and learn from the data. Selecting structures, comparisons. When showing comparisons in data, it's important to pick the right type of chart. Different structures help us see different kinds of comparisons clearly. For example, a bar chart is great for comparing amounts across categories, while a grouped bar chart lets us compare smaller groups within those categories. A dot plot works well when you have many small values to compare. For instance, if you want to compare sales of 5 products across 4 regions, a grouped bar chart is the best choice. On the other hand, choosing batch structures can confuse readers or make data hard to understand. Avoid 3D pie charts because they distort sizes, overlapping line graphs that are messy, and legends that rely only on color, which can be hard for colorblind people. Also, don't use cluttered or purely decorative visuals without explanation. as they distract from the data's meaning. Picking the right structure helps everyone understand the story the data tells. Abuse structures. Sometimes visualizations can be abused when the design tricks the viewer or hides the true story behind the data. This happens when chart uses truncated axes, like starting a bar chart at 95 instead of 0 to make small changes look much bigger than they really are. Other common abuses include using colors in confusing ways, like showing red as good and green as bad, or picking only certain time periods that support a point while ignoring others. These practices mislead people and should be avoided. On the other hand, simplicity in design is very important because it helps people understand the data clearly. A good principle is to follow dark ink ratio, which means showing more actual data and less decoration. Focus only on the essential information, use a limited number of colors, and keep the layouts clean. For example, instead of complicated pie chart with 10 slices, shadows, and gradients, it's clearer to use a simple bar chart showing just the top 5 items with direct labels. Simple designs make reading and interpreting data much easier.